I did a video that was summarizing what the hot plate was, and you people seem to love it. Today I also want to just tell you something about the flat iron. Now I've taken apart the entire plastic that is onto this, but that will not stop you being able to understand what I'm here to explain anyway. So just like the heating hot plate or cooking coil, the flat iron is similar to it. So there are actually just two or three things you need to know about a flat iron. One, it is just constituted of a resistance wire, and then two, it has a thermostat, and then three, it has a cable, and maybe you could say the body that actually allows it to have form. Alright, now the whole purpose of a flat iron is simply to provide heat, and that is achieved by a resistance wire. Now there is a resistance wire that passes through the center of this tube and goes through and comes back to this end, and for some reason that resistance wire is designed in a way that it never touches the body of the metal. So think of this tube. Let me see if I can bring another flat iron base. You see, now like this. Now this one is a bit evident if you look at this carefully. This is basically a tube, but in the center of this tube there is a tungsten resistance wire passing right in the center, and then before this is bent into that shape, sand or silica or something that can transmit heat without necessarily conducting electricity is poured, keeping the heating filament suspended in the center of this tube. And that resistance wire, when you apply power across its terminal, in most cases people would say a voltage, current will flow through it, and that will cause heat to be generated. Now the challenge is that if you applied power constantly, let's say your flat iron is plugged into the extension, this will heat up or produce heat to a point that it will become red hot, and we normally don't want that. And that's where the thermostat actually comes in. This one has been removed. You cannot use that to demonstrate. So the thermostat will come in. And by the way, in case you're wondering what a thermostat is, a thermostat is a temperature sensitive element. It can respond to temperature changes so as to break or make contact so electricity continues flowing. But again, at the very heart of the thermostat is a bimetallic strip. I don't know whether you guys went through ordinary level education, but I think you did. So a bimetallic strip is just two sheets of metal fused as one unit. The sheet of metal on top is highly expansive, and then the one at the bottom is slow at expanding. So for every degree temperature rise, the upper plate will become longer more than the the lower plate, so it will cause it to sort of bend, curl in, and that is what you see right in here. So when this absorbs heat, it bends, and then somewhere there this will make or break contact. I don't know whether you see that point in there. That's where the contact is made or broken. So that is the mechanism by which the flat iron ensures that power is not flowing through this heating filament or this resistance wire continuously. In that this is set and pre-tensioned, like when you rotate that knob actually presses this, and remember, as heat is being generated, this is trying to bend to break contact. So if it receives a lot of resistance, pressing force on this, that means it will have to be pushed with more force. That means the temperature at which it will be able to overcome would be much higher. So that allows you to set a higher temperature. So that knob that you normally rotate on a flat iron is actually attached to this by that plastic, and this will always rotate like that. That being said, of course, some of them will have temperature fuses. In case this thermostat fails, there will be a temperature fuse mounted onto the body of this flat iron closest to the heating tube, and that will actually blow at a temperature they don't expect you to be able to iron. Okay, most I don't see flat irons really exceed 200 degrees Celsius, but anyway, that said, there is also now power that comes from the socket. Of course, those come through these two terminals. One comes directly into one end of the coil, then the other one comes and then passes through that contact right there. Actually, you may be wondering how this is not able to go through the body onto this metal. That's because when you look at this very well, this is, I think, ceramic, and it helps separate this from making metallic contact with the bottom of this base. Actually, this metal never touches the body. It just comes in there, passes through that mechanism, and then from this side out to the other end of the heating coil. So this is in charge of keeping the temperature constant. I think that's enough about a flat iron. Nothing really fancy. I don't mind that most of the other parts were not around while I was explaining, but suffice it to say that this is good enough for you to understand the flat iron. So see you in the next video, and ciao. Oh, by the way, at times if you want to measure whether these things are functioning, most of these electricals tend to only rely on continuity. Continuity is simply saying that this point is continuous to that point. In other words, when I put current here, it will end up reaching there. So normally you put the multimeter in continuity mode, put at this end, check, has power reached the thermostat? Yes, that means the cable is good. Of course, this end is representing the other terminal on the plug. And then also same with the neutral side, which comes directly to heating unit. Connect your multimeter this side and that side. If it is continuous, then the cable is fine. Then my rule of thumb is to first measure the resistance wire side at other measurements leading you somewhere, because there's no point in you finding continuity of this wire yet the resistance wire is messed up. So anyway, you will put one probe of the multimeter here and then the other at that point, and then if it beeps or if it shows a resistance below 50 ohms, then you're almost confident that that heating element is continuous. It's not burnt out anywhere in the center also. Having tested that, tested the continuity of the cable, then you can also test this thermostat. Normally clockwise is up to increasing temperature, so you can put it at maximum, put one end of your multimeter here and then at the exit there. If you sense continuity, then that's fine. At times, if you don't sense continuity, it means this is most likely broken. And then also there are challenges where your flat iron keeps burning your clothes. At times, what you will do normally is set this to maximum, and in the center here there's actually a tuning screw. The tuning screw helps adjust the initial pressing force by that pin onto this. That pin is also ceramic, it's not a metal right there. It's non-conductive. So when you do that, do it when this is disconnected to power anyways. I think to prevent this video being very long, let me stop it at this and see you in the next video. Ciao.